Astronomers have discovered what may be a massive star exploding while trying to swallow a black hole companion, offering an explanation for one of the strangest supernovae ever seen. The discovery was made by a team led by the Harvard-Smithsonian Center for Astrophysics and the Massachusetts Institute of Technology. The stellar blast, named SN 2023-ZKD, was first discovered in July 2023. A new artificial intelligence algorithm designed to scan for unusual explosions in real time detected the explosion, and that early alert allowed astronomers to begin follow-up observations immediately. By the time the explosion was over, it had been observed by numerous large telescopes both on the ground and in space. The research team thinks the most likely interpretation is that the massive star was locked in a deadly orbit with the black hole. As energy was lost from the orbit, the separation of the objects decreased until the supernova was triggered by the star's gravitational stress as it encountered its dark companion. It's the strongest evidence to date that such close interactions can actually detonate a star. An alternative interpretation considered by the team is that the black hole tore the star apart before it could explode on its own. In this scenario, the black hole quickly pulled in the star's debris, and the supernova emission was generated when the debris crashed into the gas surrounding it. In both cases, a single, heavier black hole was left behind. Located about 730 million light-years from Earth, SN 2023-ZKD initially looked like a typical supernova with a single burst of light, but as the scientists tracked its decline over several months, it did something unexpected. It brightened again. To understand this behavior, the scientists analyzed archival data, which showed something even more unusual. The system had been slowly brightening for more than 4 years before the explosion. That kind of long-term activity before the explosion is rarely seen in supernovae. Detailed analysis revealed that the explosion's light was shaped by material the star had shed in the years before it died. The early brightening came from the supernova's blast wave hitting low-density gas. The second delayed peak was caused by a slower but sustained collision with a thick, disk-like cloud. This structure, and the star's erratic pre-explosion behavior, suggest that the dying star was under extreme gravitational stress, likely from a nearby compact companion, such as a black hole. This event may be part of a whole class of hidden explosions that AI will help us discover. The discovery shows how important it is to study how massive stars interact with companions as they approach the end of their lives. We've known for some time that most massive stars are in binaries, but catching one in the act of exchanging mass shortly before it explodes is incredibly rare. With the Vera Rubin Observatory recently unveiling its first images and preparing to survey the entire sky every few nights, we've been given a glimpse of what's to come. Powerful new observations combined with real-time AI systems will soon allow astronomers to uncover many more rare and complex explosions and begin to map how massive stars live and die in binary systems.